Lesson 3.5, proving lines are parallel. So we had a bunch of different postulates about how angles are related when the lines are parallel. Well, now these are the converses of those postulates. And basically, if the angles that are corresponding are congruent, then we can say the lines are parallel. So it's going the other direction. So if you can show that, in this case, converse, corresponding angles converse is what we're going to call it. If you can show that angles 1 and 3 are congruent, then that means that lines A and B are parallel. That's what the postulate says. The parallel postulate says, given a line and a point not on the line, there's exactly one line through that point parallel. And we showed that when we did our constructions last week. Now we have some theorems, converses of theorems. We have the alternate exterior angles converse, or you could say alt-ext converse. And it basically says if the alternate exterior angles are congruent, then the lines are parallel. Consecutive, remember we're changing consecutive to say same side. Interior angles converse, which says if these two angles are supplementary, then these two lines are parallel. And then the alternate interior angles converse, if these two angles are congruent, then the lines are parallel. We add to that the perpendicular transversal converse, which says if two lines are perpendicular in the same plane, then they are parallel. So if they're perpendicular to the same line in the same plane, they're parallel. That's what that says. So looking at this picture, it says the measure of angle 1 is 103 degrees, and the measure of angle 4 is 100 degrees. Is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies the answer. And for this first one, we don't have enough information. We would need to know a little bit more about a relationship between angles 1 and 3. So we don't know that relationship, or between 4 and 3. We know they're alternate interior, but we don't know that they are congruent. We don't know that information. So we cannot prove anything. So we need more information. I'm going to abbreviate information with info. If we are told that angles 1 and 3 are congruent, so now we're told something a little different. We're told that these two angles right here are congruent, then we can say yes, A is parallel to B, and we know that because of corresponding angles converse. That's why, whoops, I'm going to just abbreviate converse too. Corresponding angles converse justifies that those are indeed parallel. Now here's a question. Find the measure of angle ZYN, this angle, such that it will make it true that PQ and MN are congruent. Well, the relationship that we have between this angle and this angle is alternate exterior, and we know from our theorem that if those two are equal in measure, then the lines are parallel. So we would basically find x to make that so. So we said 11x minus 25 equal to 7x plus 35. Subtract 7x from both sides. We have 4x minus 25 equals 35. Add 25 to both sides. And we have, whoops, that's supposed to be an x, 60. And then divide both sides by 4. And we get, if x is 15, then those are going to be parallel, but that's not what it asked. It asked for the measure of that angle. So we need to substitute that in. 7 times 15 plus 35. 105 plus 35 gives me 140 degrees. That would make that true, the measure of that angle and the measure of angle PXW. That's what would make that parallel. Okay, so now we're going to prove some lines are parallel with what we are given. So we are given that L is parallel to M, and we are given that angle 1 is congruent to angle 3. And so we have the parallel marks on there, and we have 1 and 3 are congruent. Well, from there we can say that angles 1 and 2 are congruent because they're corresponding angles. And then from there we can say that angle 2 is congruent to angle 3 by transitive property. And then finally we can say that line P is parallel to line R by the alternate exterior angles converse. Pretty straightforward. Proving these lines are parallel, Carpenter's been creating a woodwork pattern and wants the pieces to be parallel. Gives us the measure of these two angles, and it wants us, if x is 15, my picture moved. Let me move that. If x is 15, show that pieces A and B are parallel. Well, we would need to show that 8x, we can do this one of two ways. We need to basically show that 8x plus 20 and 2x plus 10 has to equal 180. So we can do the check by plugging in 15 and seeing what that's equal to. So that'd be 150 plus 30, which is indeed 180. And that shows that they're parallel because angle 1 and angle 2 are same side interior angles, and by the converse, piece A and B are parallel. I wouldn't expect you to write all that. It's just because it's the notes that I'm going to write all that. Here, proving these lines are parallel. I didn't make a two-column proof here. Mark are given. We know that this angle and this angle are congruent. We know this angle and this angle are congruent. So write out are given. And that leads us to that angle 5 is congruent to angle 4 by transitive. And so then from there, we could say that this and this are parallel, which is what we had to prove. Segment AD is parallel to segment BC by the alternate interior angles converse. Because if you were to extend those lines out, that's what you would see. Those are alternate interior angles. Okay, here we are given that line M is perpendicular to line P and line M is perpendicular to line Q. Okay, but the picture is definitely not to scale. So from this information on the previous line, that tells us that the measure of angle 1 is 90 degrees and the measure of angle 2 is 90 degrees. And that was from one of our perpendicular lines form right angles. And then we have, actually, let me not write that way. Let me write angle 1 and angle 2 are right angles. Because we can't really jump there yet. And so then also we know that angle 1 is congruent to angle 2 because of the theorem that says all right angles are congruent. And then we also know finally that P is parallel to Q because of the alternate interior angles converse. Find the value of x that makes lines M and N parallel. Well, first we got to determine what relationship these two angles have. Those two angles are alternate interior angles, and they have to be equal in order for the lines to be parallel. So 3x minus 5 equals 2x plus 1. Subtract 2x, add 5. The value of x that makes that true is 6. Okay, there are some thinking questions. Whoopsies. There are some thinking questions here I want you to consider and work through, and I will see you soon.